scales are quite similar to sequential scales, except that they run from one U over a neutral value in the center to another one. Now this is different from multi-U color scales, as we've just discussed, because we have this clear center cut with values to one side of the range being negative values, for example, or values below a threshold, and the values on the other side of this range of this value are positive values or values above a threshold. Here's an example of how we use such a diverging color scale. These are income groups for specific professions. We can see that the threshold in this example is set at 50K, which, as we can learn from the legend, is the average in this data set. So all the blue values are below average and all the yellow values are above average. So looking at the ensemble of all these professions that we have here, we can see a nice shift from blue from the top to the bottom, which of course is helped by the fact that we order these individual rows, individual professions by their income and the mean, of course. But we can see nice shifts of how this distribution shifts and how much yellow there is in each side and how the yellow then subdivides into sub-bands. So really these diverging color scales is nothing else than two sequential scales attached to each other on the opposing ends. Such sequential color scales, such diverging color scales work also really nice on map data, which means where the data is spread on the screen in a two-dimensional way, such as in this heat map. So you can nicely see the differences between the red values and the dark value and the blue values alternating through this map. We then can see which values are the strongest one in each category. In this case, the lowest ones, and here we have the highest ones. And you can see some outliers that are spreading that are across the threshold. The same is true for maps, where we have, in this case, a stepwise diverging color scales for student spending in the US.